The last skill you should be coming in with is some basic physics knowledge. There is a small percentage of the AP exam that takes some basic physics knowledge and incorporates it. I would say it's about 10% of the AP exam, something like that. And so the situations in AP Calculus that we deal with is just a single particle moving along the x-axis, and we want to be able to use some physics terms to describe how it's moving. So let's talk about these physics terms we should know. The first thing is the position, and the position is just where it is. So when we talk about position, we want to say what is the x value, what is the value along the x-axis when the time is 5. Often we'll use x of t, the x value at different times, and when the time is 5, the position is 7, and that just means that at 5 seconds, or 5 whatever unit of time has passed, the particle is at an x value of 7. So it's different places on the x-axis, right? The velocity of a particle is not where it is, it's how it's moving. In case you're not sure what velocity means, velocity is the direction something is moving and the speed it's moving at. When we're talking about the x-axis, the direction it's moving is either it's moving to the right, in which case it's a positive velocity, or it's moving to the left, in which case there's a negative velocity. So this particle that is at an x value of 7 could be moving to the right, right? Okay, so it could be like sitting here, but it's also like, so at time equals 5, it is at 7, but it's busy moving to the right. Or it could be at 7, but it's busy moving to the left, right? So a positive velocity means it's moving to the right, a negative velocity means it's moving to the left. And the number value means how fast it's moving. So a velocity, v of 3 equals -2, means that we don't know where the position is, but we know that wherever the position is, that particle is moving 2 meters per second, or whatever the units are, to the left. And we know it's moving to the left because it's a negative value. And we know it's moving at 2 units per time because it's going to the left. Notice that this is always units of position per time. So if position is measured in meters, velocity is meters per second. All right. Acceleration is how fast the velocity is changing. It doesn't tell you where a particle is. It doesn't tell you how fast it's moving. It tells you how its speed, or really its velocity, is changing. Okay, so this particle that's moving to the left, well, it might be moving to the left, but moving to the left faster and faster. Or it might be moving to the left, but it might be moving to the left a little bit slower. And so those velocities are changing in some way, right? The last thing is the absolute value of velocity is just the speed. So if you just look at the number part of velocity, not whether it's positive or negative, that's the speed. It's how fast something's moving. So that comes up sometimes. So these are some basic physics terms you should be familiar with. Position is where something is. Velocity is how fast something is moving and in what direction. Acceleration is how fast the velocity is changing. It's the rate of change of the velocity. And speed is the absolute value of velocity. Okay, so we want to be able to translate this into a sentence here. The position of a particle when the time is 4 is -6. And I will draw what that means. The position of a particle at time equals 4 is -6. So that particle is along the x-axis when the time equals 4, right? And you're supposed to write a sentence that says it. I've pretty much done that for you, but you want to do it here. We want to do the same thing for velocity and acceleration. And here we want to translate this. I'll translate one of these. At 5 seconds, so at t equals 5, the particle's velocity is increasing. So this is not about the velocity. It's how the velocity is changing. 3 meters per second squared. These units can be a real big tip-off. 3 meters per second squared is going to be acceleration. It's the rate of change of the rate of change. Basically, there's some velocity, which is meters per second, but that velocity is increasing each second also. So it's meters per second per second, which is meters per second squared. And so this is the acceleration at time equals 5 is equal to 3. And we know this is a positive because the velocity is increasing. All right, some more critical thinking questions. All right, here is the position. What is the position at time equals 3? So at time equals 3, we want to find the position. This is just asking for x of 3. And so, x of 3, which is the position at 3. So we just plug in time equals 3, and that'll tell us the position. So 1/2 times 3 squared minus 1 gives you a number. At what time is the position equal to 3? Okay, so now we're looking for what the time is. Okay, so we're going to be solving for time. We're going to be, oh, this is cubed. What time is the position equal to 3? And so here, the position will equal 3 at what time we're solving this equation. Okay, I'll go over a couple ones that you might have some trouble with. When is the particle stopped? Well, here we need to think about what velocity means. Velocity is how a particle is moving, and if the particle is stopped, it means it is not moving to the right, it is not moving to the left. The velocity is equal to 0. And so we need to say, okay, at what time, when, we're looking for what the time is, when is the velocity 0? So 0 equals 7t plus 4. That will tell us, like, we're going to find the time that will make the velocity 0, and that'll find us when the particle is stopped. Okay. If v of 5 is -10 and a of 5 is -4, is the particle speeding up or slowing down? Okay, so the acceleration tells us how the velocity is changing. The velocity tells us how the particle is moving. We don't know where the particle is. It doesn't tell us, so I'm just going to assume the particle is like here. Okay, and it says the velocity at time equals 5 is -10. So that means the velocity, the particle is moving 10 meters per second to the left. Okay, and the acceleration is -4. That means the velocity is going down by 4 every second. So what's happening is instead of going 10 meters per second, it's going to be going even lower later. And so what's happening is the velocity is still going to be going negative, but it's going to be going even more negative, right? And so the question is the particle speeding up or slowing down? Speed is the absolute value of velocity. It's just how big is that number? Well, since the particle was moving to the left, and now the velocity is going even lower, the particle is going to have a new velocity of something like, the velocity at time equals 6 might be like -13 or something. It won't be exactly 4. This was exactly at that point, but it's going to be even more negative. And so what was the speed before? Well, the original speed was -10, was the absolute value of -10. But now, since the particle is going even more to the left, the absolute value of it, the speed, is going to be an even bigger number. So the particle was moving to the left by -10. Now it's moving to the left even faster because the acceleration was negative, and that made it be even more negative, but the speed is about the absolute value, and so the particle is speeding up because the velocity, the absolute value of the velocity is getting bigger at time equals 5. There's kind of a shortcut way, we'll talk about this in calculus, that you should have learned in physics, which is that if velocity and acceleration are in the same direction, if they're both negative or both positive, the particle will be speeding up. And that should make sense, right? If the particle is going a certain direction and now it's going even more in that direction, it's going faster. If the particle or if the acceleration and the velocity are going in opposite directions, so the particle was going in a positive direction, but now it's now going slower because the acceleration was negative, that will make it slow down. All right. Well, hopefully this is a good introduction to some physics stuff you should already have if you didn't have it.